So I'm Dr. Shantanu Chakrabartty, and this is Adaptive Integrated Microsystems Laboratory. So in this lab, the designs, they start from the whiteboard, where we start with equations, you solve some models, you simulate them, and then we try to put these equations on these chips. These chips are actually solving these equations. PhD students in this lab get an end-to-end experience, which means that they start from a concept where they know that there is a fundamental problem that they need to solve. That forms the part of their PhD thesis. Once they have formalized the problem and they look at something new in that domain, then the goal is to apply it into the real world.
My research in particular deals with understanding the noise and the variations in environment factors on the systems and its performance. So research in a lab is not just limited to the theory and lab experiments, but also translating most of the research into practice, which requires actually for us to test some real world conditions. And that's where we have this setup where we can actually simulate the temperature and humidity conditions and actually verify our chips in practice, and then use our chips and deploying them anywhere we want. So this not only helps us understand the performance of our system in real world conditions, but also help us to understand how to design the systems before we actually approach in making them.
Right now I'm talking about some kind of timers which run without any batteries. So they are like clocks but no batteries. Basically you program it once and you leave it, and when you again read the value, it will have changed, and that how much it has changed depends on how much time has elapsed. I hope my research will do is replace both of these chips with one much smaller chip which we can implant inside the brain of the locust and then seal it up.
I am working on this wireless neural recording for locusts. So basically what this is ideally going to allow us to do is record these signals from this insect while it's moving in a mobile or deployment style environment, and transmit it wirelessly back so the user can see it and hopefully make some sort of informed decision about the information. Originally, the project that this started from is using these as actually bomb detectors. So the locust is going to go in, kind of explore an environment that would be potentially dangerous for humans, and hopefully smell the explosives and collect the information and then transmit it back wirelessly.
We're adding sensors to bridges such as the Mackinac Bridge, and we are collecting data self-powered, and we don't require any battery power for this. And we can collect a continuous stream of data, and we can extract some sort of history of what the strain levels have been inside the structures.
The project itself is called Electronic Tooth. The goal of having this kind of electronic tooth is to replace pricking the fingers in order to get the blood, to measure, for example, the amount of sugar inside the blood. So the same thing existed in the saliva. In order for that electronic circuit to be functional, it requires a power, but nobody wants to have a battery inside an oral cavity. We created this technology by delivering the power wirelessly. We can get the data also using an antenna inside the room to measure that without having any non-convenient way to get the blood from the fingers or something like this.